We finally got the engine pulled from my 2012 Chevy Silverado pickup that has been broken down for over a year now. The engine is a 5.3-liter Gen 4 LS, specifically an LC9, which came from the factory equipped with both active fuel management and variable valve timing. As many of you probably know, AFM is the weak link in these engines. In my case, I experienced a misfire on cylinder 6 after one of the AFM lifters got stuck in a collapsed position. While the fuel savings goal of AFM is admirable, the less than 10% increase in fuel efficiency comes at a heavy cost when you consider the significantly reduced reliability of engines with this system. Now, most people faced with this situation are probably going to swap to a non-AFM cam and lifter set and be back on the road, but considering we have the machine shop here and the engine did have 150,000 miles on it, I figured why not go through the engine, maybe do a few minor upgrades, and gain another 150,000 miles of life out of it, hopefully. Inside the engine, I found nearly no cylinder wear, nearly perfect bearings, and just some slight scuffing on 4 pistons. So with that being said, the extent of the machine work that was going to be required was pretty minimal. After cleaning the block, I made the decision to go ahead and square up the decks of the block on our RMC 1000 boring and surfacing mill. Bimetal blocks like this, which have a deck surface that is both aluminum as well as cast iron, can be tough to surface and get a nice finish. The insert that we have found works the best is a hybrid PCD from Performance Plus. You do have to run very slow and periodically spray the insert with WD-40 or something similar to try and keep the heat down, but the end result is worth it. Each side of the deck only took a couple of thousandths to square up, and we came out with that perfect mirror finish, even near the cast iron where the normal CBN would typically drag. Considering the block had minimal wear, I opted to hone the cylinders for a 5 thousandths oversized Icon Premium Forged piston set. I have to say I am impressed. These pistons look and feel great. They have a flat top with the formed valve reliefs and a coated skirt, but UAM is also good about leaving a pad large enough to get a micrometer on, which is super nice. The set was weight matched well, and all 8 were right on size within a reasonable tolerance. And if you're wondering where you can get a set, we sell them and thousands of other part numbers on our website. So be sure to support us by visiting the links in our description. Given the guidelines provided by the piston manufacturer for this alloy, I decided on setting our clearance at a minimum of 3 thousandths piston to wall, given the application of this vehicle. With the mic set to the diameter of the piston, I set the bore gauge so that the 0 point on the gauge would give us that 3 thousandths piston to wall clearance. With the main caps torqued on and the block set up in the cylinder hone, it was time to get a torque plate installed. Ideally, you should use a head gasket as well between the deck and the torque plate to most accurately simulate the stress of torquing the cylinder head to the block, but the customer spent all his money on fancy pistons. It was too cheap to waste a head gasket. I like to go with the ARP head bolts because the factory bolts are torqued to yield, so you really shouldn't use them more than once, but the ARP bolts can be torqued multiple times and be okay, which works great when you're wanting to hone with a torque plate. Since we have around 5 thousandths of material to take out, we're going to be using a process with 3 different grit-sized stones here in the hone to remove the material. Starting with a rough stone that can remove material more quickly, but leaves a coarser finish that is less than ideal for a finished cylinder. This is an exaggeration, but for those of you who aren't familiar with honing, think about 80 grit sandpaper. Typically when an engine comes in, there's going to be more wear at the top of the cylinder than at the bottom, sometimes leaving what is known as a ridge that can actually be felt at the top of the ring travel. In the case of my engine, I found that the cylinders had very little wear, with the exception of maybe 3 to 4 thousandths at the very, very top, which almost couldn't even be felt. Starting honing here on this first cylinder, I go slow just to make sure that I don't crash the stones into the webbing since it is the first cylinder that I've honed on this side. Then we can get into it and kind of just let the machine do its thing, keeping an eye on the load meter, which if you've seen some of my previous videos I talk about because it'll help you detect which parts of the cylinders are tighter and which part of the cylinders are looser. After just a few honing strokes, I wanted to show that the dark line seen at the top of the cylinder there is the wear. So you can see it really is only at the very top of the ring travel in this case, and the goal is that all of this will clean up by the time we get to our finished bore size. With the rough stones in, we'll go through and do our bulk material removal from this bank of cylinders, and in this case, bringing the diameter out to between 1.5 and 2 thousandths tight from our finished bore size. It can be a tedious process, but we're really going to take it slow and work to get the cylinders as straight as possible at every step of the way, so that we're not fighting any taper or any tight spots as we get closer and closer to that finished bore size. Again, it's also important to check every point in the cylinder from top to bottom just to make sure that you don't have any tight spots or anything going on funny that you need to adjust the machine for. And as you can see, all of that wear is gone and we don't see any shadow at the top of the cylinders. At this point, we're going to move to a finer grit stone, which, for an easy explanation, is going to remove material less quickly, but it's also going to leave a nicer surface finish. This stone, I have a little bit of damage there on the bottom from a previous point when I crashed the stone, but it's still fine. It's going to work okay. Now with these stones, I'm going to bring it to within a 0.5 thousandths of our finished bore size, and it's really the same process. Just kind of work through every single cylinder on this bank and taking our time, checking our size every step of the way, and making the adjustments if we need to. For instance, there I was dwelling at the bottom because I had a tight spot in the bottom of the cylinder, and there we're watching the load gauge again, and you can see that gauge is bouncing back and forth. When it's higher, that means that's a tighter point in the cylinder, so I'll start to dwell at the top there, and that kind of evens out the gauge. Obviously, it's not a perfect solution. The better option is always to measure with the bore gauge and keep an eye on where the tight spots are so that we can get the cylinder perfectly straight within reason. Nothing is perfect. Dwell feature is new for us if you saw our previous video, so I'm still getting the hang of it. And honestly, I'm still wishing I had a newer CNC hone that would work its magic for me. But for now, the dwell feature has been a great addition to this machine. I know the difference is hard to see, but the cylinder on the right is the rough stone, and the cylinder on the left is the finer stone. Once we have about a 0.5 thousandth of material left to remove, I like to move on to a third stone, which is an even finer grit. Unfortunately, I do not own a profilometer yet, so I can't give you the quantified surface finish numbers that this process yields us, but I can tell you that it hasn't let us down yet. Ideally, at this stage in the process, our cylinders are already straight, but even here I was doing a tiny bit of touch-up with a dwell at the top before doing our final 10 strokes or so. My goal was to be on our minimum size for 3 thousandths piston-to-wall clearance, with no more than a 0.5 thousandths variation in size at any point in the cylinder. I should note that as you're honing, the cylinders do heat up as well, which affects your measurement, so it's important to let the block cool one final time before you do your final strokes. And here for one last comparison, the right-hand cylinder is at the medium grit size, the left hand is finished. And again, doing our final check here on the size from top to bottom, I wanted to be at a minimum of 0 on the gauge and a maximum of a 0.5 thousandths or 1 mark. So we're right in that range, which means we're going to have our perfect 3 thousandths piston-to-wall clearance or just a little bit more. The last step in our process is to do a few strokes with the plateau brush, and basically that takes away any jagged edges that are left from the honing process. So at this point, we're finished with the block in the cylinder hone here. You can see the cylinders look great, the deck looks great, so there's only one last thing that we need to do on this block, and that is to plug the Afm Towers, which are the oil passages that are used to actuate the mechanism in the Afm valve lifters that turn on and off these 4 cylinders. You don't technically have to do this if you use the right valley cover, but I want to do it as an extra peace of mind, so basically what I did is drilled out the holes and tapped them for a 1/8 pipe plug. With all the machine work done, I did the final wash of the block, and here we're getting ready to install the camshaft bearings. I went with the Durabond performance bearing just because the LS have some bearing problems. After I got the bearings installed, I test fit the cam and then moved on to installing all of the plugs and the head dowels. Here we're installing this brass plug on the side and then getting all of the oil gallery, however you want to pronounce it, getting all of them installed, getting the freeze plug in the front of the block installed, and the barbell in the back of the block. We're also installing all of our pipe plugs in the Afm Towers to be just flush, and man, when this thing was done, it looks beautiful. It looks like a brand new block, to be honest, and I'm so excited to get forward to building this engine and get it put back in my pickup so that I don't have to drive my car all the time. As always, be sure to like and subscribe, and stay tuned for the upcoming videos on this build.